So, now, André Duarte from Betfair. Thinky Betfair.
Can we get a presentation over there?
Eu sabia. Queres que eu diga Gillette no próximo?
All right. Okay. So good morning, everyone. Well, AngularJS pushing the browser to the limit. First, let's start by seeing how many of you guys do use AngularJS, or have you ever used AngularJS? Please raise your hands. All right, there's a lot of people. Oh, nice. Well, but the rest of you don't even think about taking a nap right now, because this is not gonna be, well, actually this is gonna be about an AngularJS application, but the problems that I'm gonna talk about, they are pretty common on single-page applications that render on the client side. But first, who am I? My name is André Duarte. I was born and raised here in FEUP as a software engineer, class of 2007, the best one. I'm currently a senior developer at FEUP. I have been working for the past 3 years, mostly building the Betfair's mobile web application. And I guess you guys know the brand Betfair. I'm sorry it's not available in Portugal right now, so you'll have to trust me on what I'm about to tell you because you can't actually test it. And we are a sports betting application, and we have the an application for web, for iOS, and for Android. Although we support those 3 platforms, the application is just one. It's the web application. Then we wrap that code into some native code, and so as to offer in the native stores. We have currently 1.7 million active users, and because of that, sometimes we have a peak of users that goes up to 100,000 users accessing our website simultaneously. And that makes it really difficult for us in order to have that number of uptime, 99.9%. So scalability is really important for us. Well, let's first go back to a time where JavaScript was thought to be slow. Back in 2010, we had a completely different application. And the application was mostly living on the server side through a Java-based Spring backend application. This application, once you access our website in the browser, the server side would generate a nice HTML document that would then be sent to the client. And with that document, we also sent a very tiny, very thin JavaScript client, so in order for us to be able to do updates and form validation and all those kinds of things that you actually needed to use JavaScript for. Now, fast forward to 2015, a lot has changed. And for once, one thing that really changed a lot was these phones. I mean, these phones nowadays have more power in them than the desktop computers that we had 5 or 10 years ago. Well, you don't even have to go back 10 years ago. And so a major shift in our technological stack, because JavaScript started being fancy, you know? Actually, Brendan Eich, the creator of JavaScript, when he was presenting ECMAScript 2015, he actually ended his presentation saying, always bet on JavaScript. I'm quoting him. So since this is a betting application, we pretty much have to follow his advice. So we rebuilt our whole application using only JavaScript, but with a major shift in terms of architecture, because the old application was mostly living on the server side, but the new application is now mostly living in the client side through an AngularJS application. Our server side is also written in JavaScript because it's Node.js, but we only have small microservices that feed some data to the AngularJS application. And we wanted to use all the latest technologies and all the good practices into building this application. So we had a modular application that consisted of several modules, everything stored as NPM packages, and then by using Gulp, we automated a lot of tasks to make our app just very efficient. Like we were using ECMAScript, but then ECMAScript 6, but then we had to transpile the code because the phones can't handle ECMAScript 6 yet. we were doing a lot of unit testing. Actually, we invested a lot in unit testing. We have about, I think, 95% of code coverage in our application. SVG sprites with PNG fallbacks and all kinds of optimizations, everything automated with Go. And we also automated most of our QA processes, which was really, really cool, because by automating our quality assurance, we could incrementally test our application so that when any developer committed some code to our existing code base, the application would be automatically tested, and you could be sure that you could release to production in minutes with safety. And that is really cool, right? So when I show you this scheme, you see all these new technologies and everything is great. But once our application started growing very big, let's see a comparison between the old Java-based application and the new AngularJS application. That's the old one is on the left, the new one is on the right. Let's see a comparison between the two of them when they render on a low-end device with flaky network conditions. So let's take a look. I have to click it here, sorry, because it's YouTube. Right, so on the left we have the old one. And as you can see, we have a very, very fast first impression, while the other one is still loading. And it's finally done. So, in order to understand this, why was this happening, let's first try to analyze what was happening in the old application. As I said, the old application was living on the server side, so everything started by downloading a big document. This document could go up to 300 kilobytes. Actually, it was average 300 kilobytes, but it could go easily up to a megabyte of code if the page was too big. But after downloading that document, then what do? You download basically the CSS and just a tiny bit of JavaScript, because you barely have JavaScript in that application. Then you download the third parties, and then you have a bit of scripting in order to initialize the client. But what's interesting here is that midway through the process, once you get the CSS ready, you can already render the application, and the application actually looks ready. It is not ready. You are not ready to bet yet. So you saw a very quick first impression that wasn't a fully loaded application, but this makes a huge impact in terms of user experience. Now, on our new application, things are a lot more different. For starters, forget about the index HTML, because the HTML document on an Angular application is not really a document with content. A document for an AngularJS application is just a vehicle in order for the browser to download both the JavaScript and the CSS that you need to actually render the application. And apart from an eventual loading message or a spinner over there, you don't have much content. So forget about that, because it's super quick to download. It basically doesn't count for anything. Now you start downloading the assets, and just try to think about the shift that we did. We shifted from the server side to the client side. So instead of sending the client the result, we are now sending the full application. So that's about 600 kilobytes of JavaScript. After those 600 kilobytes of JavaScript, then you start downloading the third parties, which is weird. We're going to talk about that later. And then finally, you are ready to start your application. Now you still need to go back to your servers, fetch the data, come back, script all that AngularJS goodness, and finally render and painting everything in your browser. So these are our major three problems, and let's start by tackling the biggest one of them all, the scripting. So because this is an AngularJS application, you pretty much can't get away from scripting, because since you don't have a pre-rendered document, while the browser is scripting, you can show him content. You can try to fake your content, just render a placeholder so the user experience is not as bad, but you can't render content until the scripting is finished. So you should try to keep your scripting as little as possible, because these are mobile phones, and mobile phones, they are very powerful nowadays, but they're still not as powerful as that MacBook over there. But they have a great, great advantage. Look at the size of this screen. It's super small. And actually, this is an iPhone 4, but that's an iPhone 6. That's one of the biggest viewports we support. But still, look at that. That doesn't look like much work, right? It's like 6 buttons, some titles. That shouldn't be much work. But once you start scrolling down on the application, you start seeing that you are rendering much more content than the user is seeing. And in the case of our application, we were actually render just on the homepage 13 times the viewport of what the user was seeing. And if you plot that against your data fetching and scripting problem, you may see what you're doing wrong here. You are just pushing your browser way over its limit. Because even if you do the most efficient JavaScript code, if you need to do all that just in order for the user to see that little piece, it doesn't really make sense, and you just gotta do less. And that's how this library called ngLazyRender was born. This is a library that was created by some bleepers, me included. That's one man clapping, that's my internet name. And what this library does is really simple. So imagine this as your homepage. All of these modules, this is a continuum of the application. We just make everything that the user cannot see lazy. Because if I went to talk to my product owner and tell him, I need to render less content to the user because the application can be slow if I render too much, he will just tell me, of course not, because I'm not going to reduce the features to my user, and that makes sense. But you don't really have to do the work for features that the user can see. And if they are outside of the viewport, by using this library, what it will actually do is replace the content of those visual modules for placeholders that look like them. And then, as the user starts scrolling down and approaching those modules, that's where you start rendering them. And by doing work little by little, instead of doing it all at once, you get a nice user experience. So take a look, that you almost can see them being rendered. Look at that. You're scrolling and you're building the modules as you scroll. But since you're doing work little by little, it's almost unnoticeable. Let me just get some water, sorry. Now, if that's difficult, if it could be difficult to negotiate with your product owner, just try thinking about negotiating with the whole Golf Open Championship in order for them not to have so many candidates for a winner title. I mean, I don't think you can do that, right? They have over 100 runners, and we need to present them all on our website. But the thing is, once again, we don't need to render everything at once if the user is only seeing a small part of it. So by using this library, what you can do is just render that little bit, and then as the user starts scrolling down, you start feeding more and more content. And once again, because you are doing this little by little, the impact on the user experience is very small. Just take a look. As you scroll down, you'll see content appearing. You can see a bit of flickering there. That's the content being created. But since it's little by little, it doesn't have much impact. Where it does have impact is on the actual timeline of the application, because with this, we were able to save more than 60% of the scripting that we were doing on the initial state of the application. So you get an application to be ready much, much faster. And then you're not saving all that scripting, but you only start that scripting once the user starts interacting with the application. Now let's move on to the second problem, the third-party scripts. I mean, third parties being downloaded before the application is ready doesn't really make sense, right? And that's not usually what happens. And actually, on the old application, that didn't happen. We were downloading the third parties after it looked ready. So let's go back a little bit until to a classic web standard that says you should never include script tags inside of the head tag. Because if you do this, it will make the browser have to wait for that script to be downloaded in order to show the content. So a good practice is usually to put your script tags inside of the body tag, but after all the content. And that's what most of the third-party websites will tell you to do, because it makes sense. But when you have an AngularJS application, things are a lot different. Because even if you put your third-party scripts inside of the body tag after all of the content, first, you have no content. Second, even if you put them after your essential core scripts, that doesn't mean that it's going to be less priority, because what the browser will try to do is actually download them all at the same time, and as a consequence of that, your third parties will be competing for your phone's resources against your own core application, and that doesn't make sense. And that's especially a problem if you don't have an application that has one or two scripts, but have an enterprise application that includes dozens and dozens of third parties. So we need to find a way to include these scripts after we know that the application is stable. But how can you know if an application is stable? Well, we found a very simple heuristic to be actually very useful and very right to solve this problem. So once you open your application, your Angular application, you'll start getting a lot of HTTP requests. So if you just try to count how many requests you are sending to the internet and how many responses you are receiving, when that number is the same, that pretty much means that the application is now stable. And when you got a stabilized application, that's perfect because it now has a nice user experience for your users, so you can start downloading the third parties. And for that, we also created another library called ng on HTTP stable. It was created by another blipper, and what it does is really, really simple. On an AngularJS application, it just allows you to postpone the execution of code until a point where the application is already pretty much rendered. So, by doing this, we not only could increase or decrease the amount of time that we have to wait in order for the application to be ready, but we could actually render that placeholder of the application much faster, because right now we don't have anybody else competing for our assets. And can we be even lazier? Of course we can, because when I said that we were downloading 600 kilobytes of JavaScript, I wasn't mentioning that that's after compression. Because before compression, we have a really big application. We actually have 2 megabytes of JavaScript that actually mean 100,000 lines of code. Do you really need 100,000 lines of code to just render a page? It's pretty dubious, isn't it? But it's actually very difficult to evaluate that number for sure. But in terms of CSS, it's really easy to do that evaluation. You can just find a Chrome extension that will do you that. And in our case, out of the total 800 kilobytes of CSS, we were just using 40 kilobytes on the home page. That's about 5%. But how can you divide your application instead of being per file? Because if you are dividing your application per file, this is what's going to happen. Your users will try to access an address. That address will download a file, then that file has 2 dependencies. Each of those 2 have 5 dependencies, and then you get like 50 files in your phone. And that's a really, really bad idea, especially on HTTP1. So generally, a good practice is to bundle your code together. So you get all of your JavaScript, you place it into one file, and then that enables a lot better minification and compression, because you can see that from the 2 megabytes of code that we had, we could compress it down to 600 kilobytes. But the thing is, this is a good technique for small or mid-sized applications, but once your application starts growing really big, so does the bundle, up to a point that it may not fit inside your phone, because you don't want your application to grow into 3 or 4 megabytes and demand that the users have to download those 4 megabytes in order just to render a page. So the solution for that needs to come from a modular application. But this is software engineering 101. This is not just a web thing. You should really have a modular application. Because if you have a modular application, you can do a pretty much smarter way of bundling. It's just a matter of you being able to draw the line and separate the different parts of your application into contexts that make sense to the user. not to you as a developer, but mostly for the user. So you should divide, well, this is an example from us. We divided more or less between what would be the core modules that are shared among all the pages of the application, and then we can have some bundles that are related to settings, to help pages, to football pages, etc. And once you do this division, this is the result that you should have in terms of bundling. Instead of having many files or one big bundle, you should have small bundles of code. And if you use another library on AngularJS called OC Lazy Load, this library will enable you to be able to lazy load files in AngularJS, which is something that Angular does not allow out of the box. And by just using it, you can relate routes to bundles of file. So instead of having this experience where the user will fetch the same bundle regardlessly of the route that is trying to access, you get this. Or again, dividing your work into smaller chunks. The user visits the home page, downloads the core.js and the home.js. Once the user navigates to the horse racing, he already has the core.js, so he'll only download the horse racing.js. So that's really cool, because it allows us to make that assets part really, really small, because now you just gotta download the core assets plus the ones on your page. And once the user starts playing with the application and changing pages, then you will eventually download some extra assets. So let's recap a little bit on what we did. We started with an application that had to wait for everything in order to show something to the user. Then by using ng-lazy render, we were able to postpone more than half of our scripting up to a point where the user started interacting with the application. Using ng on HTTP stable, we were able to put the third parties in the right place, accelerating the app-ready experience. And by using OC Lazy Load, we divided our assets into what's core and what's relative to pages, and make even a faster experience in terms of app-ready, and the user download a lot less code. So let's watch the result of just applying these three libraries to an existing AngularJS application. I'm sorry that they are a bit different, but that's because the left one is an older build that doesn't have these optimizations. Just take a look. All right, it started to load, and you can see a spinner much faster than that one. And look at the time that's going to spend scripting, almost anything, while the other one is still fetching. And now scripting and finally done. So with just applying those three libraries, you can make, at least this application was about 2.5 times faster to load. Should we stop now? Well, unfortunately not, because that's the life of who tries to fight with web performance. Because if your application code is mutating and growing bigger, you start having more problems. But fortunately, technology is also growing constantly. So we can't do this right now, but imagine that in some months, maybe we can start sending instead of bundles of code, just all of the files, but using HTTP2, which would be really cool for the users. We can provide non-transpile JS bundles for phones that actually support the ECMAScript 6. Well, this list could go on forever and ever and ever, but that's just to show that we couldn't include it all in this presentation. But if you are interested about these themes, you can follow my blog. I try to write some articles about performance in there. You get some links to the libraries that I mentioned. And, well, I think we have time for some questions, but you can ask me anything on Twitter. Thank you very much.
So, after seeing a beautiful solution of divide and conquer.
Exactly, divide and conquer.
Questions?
Please. I don't want difficult questions, but easy, only easy
is this what, okay. So you're pretty much building Betfair.
Yeah.
which means that, and we're having the Euro 2016 right now,
Yeah.
which means that many people in France are on roaming, and on
Yeah.
roaming 1 megabyte can cost like €1 or €2 to download.
Yeah.
Which means that going into your application already has a £1 or £2 cost
Yeah.
just to download.
We don't have a megabyte of code though. With the optimizations, and especially, we didn't even have before because of the compression. After the compression is actually 600, so it's even less with the optimizations. But I see your point. Yeah, it can be difficult for people that pay per megabyte on their phones. But the thing here is that you pretty much can't get away from that with building a rich application. Because even if you didn't have client-side rendering, you saw the size of the document that we were downloading when we had server-side rendering. Because it's a very rich web application with a lot of information, you can never download less than, I don't know, 400 kilobytes. So maybe it's better to invest a little bit more in terms of assets to increase the experience a lot more, I would say. More? No more questions? Was it that clear? Oh, my friend Tony.
The videos.
If you are doing this change today, would you still use Angular?
If I would use AngularJS, well, of course, because I love the AngularJS community. But if that question is, do you mean between AngularJS and other similar frameworks, or more between server-side rendering and client-side rendering?
Server-side rendering and client-side rendering.
Well, then absolutely AngularJS and not the old stack, because as I presented, our numbers are not as big as Spotify's, but scalability is really important for us. And to scale an application that renders on the client side is so much easier than scaling an application that has to render on your server side, because just think about rendering one web application, a full web application, 100,000 times in your servers, or just sending some data and try to let's call it, divide all that work into 100,000 different phones and not your servers. And that's the major advantage for us. So yeah, I would still keep the client-side solution. And then you can also do a lot better code, actually, because communicating constantly between server-side and client-side in terms of HTML content is not a great thing to do.
I think we have one more question over there.
Please.
Let's change sides.
Thanks, André, for the presentation. It looks like you guys are doing quite an amazing job. With all this hype around server-side rendering, I would like to know if you guys have made some kind of experiments, or if you have an opinion, if it would help your cause, so to speak. That would be my question.
We made some experiments, but with AngularJS 1, and they didn't go very well. AngularJS 2 opens a window to server-side rendering from out of the box. So eventually, we may try a solution like that. But the thing is, once again, scalability. Angular Universal, which is the framework that actually renders on the server side and then spits the content into your phone, it seems pretty usable, but we don't have enough data already to understand if it can scale to a point where we can serve that server-side rendered version up to 100,000 users, or actually if Angular 2 will be stable in 6 months, maybe that number will even grow more. So we need to be sure about that, and we just don't have the data yet.
Thanks.
Thank you. Anyone else?
We still have time for one question. Or you can just try to...
Well, you got my Twitter. Oh, you don't have my Twitter handle over there. Or else I would try to read if someone made me a question. Well, actually, yeah, but it was Ron Valente. He just asked me. Nobody else.
No? Well, Thank you, André.
Thank you very much.